Hello, I'm Laili Jannatain from Pharmacy Class B. This is a summary of material from Professor Drive. Prasad Kaparaju, Professor of Biotechnology and Renewable Energy School of Engineering and Built Environment, Griffith University, Brisbane, Australia, on the smart icon. Chemical composition and methane potential of sugar industry byproducts. Different substrates that we have tested and you can ball on the amount of material and you have added. You will see this that the methanol per cubic meter OD methane per ton of fresh material and the highest was coming from the evaporated sugar syrup. Means that it is basically rich in sugar, so that means it is able to give you full potential, whereas the LYIC materials, it's a kind of LYIC non-silic matrix, so the bacteria access to this organic material is limited by the recurrent materials. So using those methane potentials, you can then study the feasibility of biogas production from sugar industry wastes. The idea is to see what technology we can use. In what different scenario the use of biogas do you want to produce biogas for heat and electricity production in a combined heat and power plant, or you upgrade the biogas to biomethane, means it is almost equivalent to your natural gas grade quality, and then inject in the natural gas. And the third one is upgrade the biogas to meet the natural gas quality and use it as a vehicle fuel that is called the bio-CNG, compressed natural gas. The injection into the grid, we call it as a bio-RNG, renewable natural gas. These three users of the biogas have been considered in this study, and then we try to see how much the economics looks like and whether these projects are viable for the sugar mill if they diversify as the biomass like a sugar can. Biogas trash and mill mud. The overview process. At the left there is sugarcane biogas, sugarcane mill mud, and then co-digestion with the chicken manure. The sugarcane biogas and mill mud will go through a pre-treatment process so that the particle size is reduced, and also the steam pre-treatment will improve the solarization of the cellulose and hemicellulose and thereby improve the methanol. So they are then mixed with the chicken manure and fed to the biogas reactor. Now in the biogas reactor, you will see that the gas is produced and the gas is then stored and then put into the three different scenarios that we are talking about. That the gas, it's completely used for combined heat and power plants to produce heat and electricity, or it can go through a biogas upgrading process to produce a bio-CNG, which is basically a vehicle fuel, and that can be used in the dual fuel vehicles for actually replacing the petrol in your engines, or you can also upgrade the biogas to a bio-RNG natural gas quality and injected the natural gas grid. These are the three different scenarios that I am testing in these process, and then the residual material from the biogas plant, we call it as a digestate. That is still rich in the nutrients, because all the nutrients are conserved in this process. So you can then use it and recycle them back to the sugarcane cultivation. And it's called a sustainable environmental technology, where the carbon is recorded as a renewable gas and then the nutrients are conserved and recycled as organic fertilizer, so you will be self-sufficient in terms of energy and the nutrients. The one scenario here, you can see that the process, I have done the calculations from the engineering pop about how much the materials are actually fed to the biogas plant every day. What are the sizes of the biogas plants and how much the mass and energy balance. Every day you will feed about 151 tons of the feedstocks. It will be about 82 tons per day of mill mud, 55 tons per day of sugarcane biogas, and then 14 tons per day of chicken manure. And you also need some water to make the solid contents to be below 10%. So that material is then fed into these three biogas reactors. Thank you for watching. Bye bye.